This is the final week of lessons about binary maths. In this lesson, we'll learn about how to correct errors in the presentation of floating point numbers, and that's called floating point normalization. So in this lesson, we'll look at what makes a normal floating point number and how to correct or normalize a number which is not in the right form. We'll go through a worked example and finish with a test. So when a mantissa is in its correct or normal form, it begins O1 or 10. We always make mantissas in that form. There's a couple of reasons. One is it's a sort of conventional way of representing numbers so that all computers can use the same system. But the reason this system is so good is that it allows us to get maximum precision from the available bits. That's because a whole load of ones or zeros at the start of a mantissa is effectively wasted space. It doesn't change the value of the number. So this is a convention, but it's a convention for a good reason. So sometimes when you look at a floating point number, you'll see that the mantissa is wrong. For example, after a big complicated calculation, you might end up with a number that's not in the right format. But it's quite easy to put it right. We adjust the mantissa and the exponent so that it's then represented in the correct format. It's very important that as we do this, we don't alter the numerical value of the number that is stored. And as you will understand from what I've been saying, this process is called normalization. So let's see how we do it. It is usually quite a straightforward task. So to normalize a floating point number, we move the mantissa to the right. That is, we look down the mantissa to find the correct pattern, and then we reduce the exponent by that amount, and that retains the numerical value of the number. So let's look at some examples. Here's one that you might typically be given in the exam. You can easily see that this number is not in the correct format because it begins with a string of 4 zeros. The value of the exponent is 3 plus 3. The value of the exponent is 2, positive 2. Okay, so the first thing we've got to do is adjust the mantissa. I expect you can see it already, but let me highlight it. There it is. There's the correct mantissa that we need. Because this is a positive mantissa, it begins with 0. So we don't need all those zeros at the start. We just look for the first pattern of 0, 1. And now we have to adjust the exponent so that the final number has the same value as the number we started with. So we've moved the mantissa along by 3, or to put it another way, it's 3 hops to get back home. So we subtract 3 from the mantissa. At the moment it's 2. Subtracting 3 will give us -1. So the mantissa is now -1. To make things even easier, it's always a subtraction with normalization. You're always looking along the mantissa to find the pattern that you want. So it's always hops to the left, and so we always subtract from the exponent. So I've just set out the results on one slide so you can have a look at it. That's an unnormalized mantissa exponent pair and then the normalized version. And if you turned both of those into a fixed point number, they'd both turn into the same fixed point number. And if you look here on the red version, the normalized version, you've got spare zeros at the end rather than at the start. And that means that you could get more precise if you needed to. You could have smaller fractions, whereas the zeros in the black text version are just wasted space. And I had already mentioned this, but did you notice that when you normalize the mantissa, we'll always have to move the point to the right to go up to further down the mantissa, and that means to correct the exponent, we'll always be subtracting from it. So normalising always means reducing the value of the exponent. So let's look at another example. This time we've got a negative mantissa. The mantissa begins with ones, a line of ones, so it's not in the normal form, and the value of the exponent is 3. So we've got to find the right mantissa. The mantissa is a negative number, so we're looking for the pattern 1, 0. And there it is, obviously. So there's our mantissa. And now we have to adjust the exponent. We've moved the point by 2. So it's 2 hops to get it back home. So we subtract 2 from the mantissa. And 3 minus 2 is obviously 1. So the mantissa becomes, the exponent becomes 1. So find the mantissa, adjust the exponent by subtraction. That's literally all you have to do to normalise a floating point number. And the one that we've just done, the exercise we've just done, there's the mantissa and exponent we've begun with, and the one that we've ended up with, which has got free space to the right so that we could manage with increased precision if we needed to. So it's the most effective way of storing a number using floating point. Okay, so let's just recap. In a normal, if a floating point is correctly represented, then the mantissa must begin with 01 or 10. And if you see a mantissa that's not like that, you normalise it by moving the point along, and so that we can preserve the number value of the floating point number, we normalise the exponent to, and that's always a subtraction. So here are some exercises. I've shown you 3 mantissa exponent pairs. None of them are normalised, so normalise them and check that you've preserved the numerical value by converting both the normalised and unnormalised versions into fixed point numbers, because they should both convert. If you've done it right, both versions, the correct and the incorrect version, should both turn into the right fixed point number, the same fixed point number. And then if you've got time, go on to convert the fixed point number to decimal. Now in the exam you'd only do these extra conversions if they explicitly ask you to, but I'd like us to practice. This is our last week with binary numbers, and it's quite important that we get our skills to the max, that we hone our skills so that we can do these conversions without very much stress. So I'm going to invite you to pause the video now and do these 3 activities, and then come back whenever you've got it done and watch the last few minutes of this video. So I'll just pause now so that you can stop the video. And here are the answers. So do check your work and make sure that you have ended up with the correct result, both of normalization and of conversion. And if you have, well done. That kind of means that you get it, that you're there in terms of floating point numbers. There's we're going to learn about floating point addition and refresh some of the things that we've done. So a couple more lessons about floating point this week. So see you in the next lesson. Bye for now.